Okay, let's look at the next question. We have to calculate the ratio of the time taken by the particle executing a simple harmonic motion to travel from x equal to 0, that's the equilibrium position, to x equal to a by 2, and from x equal to a by 2 to x equal to a. We have to calculate the ratio of the time it takes to do that. Alright, let's make a quick drawing for this. Okay, let's consider this to be our straight line motion, this just to be the line along which the particle is executing simple harmonic motion, and let's consider this to be the equilibrium position, and you have x equals plus a and you have minus a. Okay, we need to figure out the time it takes to go from here to here, the ratio of the time it takes to go from here to a by 2 and then from here to here. Okay, so let's say the time taken to go from here to here, let's call that time as t1. Okay, so from x equal to 0 to x equal to a by 2, let's call that time as t1, and the time taken to go from here to here, let's call that as t2. So from a by 2 to x equals a, let's call that time as t2. I want you to first think about which time will be greater. Time it goes from here to here, that's t1, or the time it takes to go from here to here, t2. Well, notice that the distance traveled is exactly the same, but the velocity keeps changing. Remember that the speed is maximum at the equilibrium position. So the particle is very fast over here and it slows down and gets 0 speed right over here. So using that intuition, we should be able to come up with a reasonable idea as to which one is higher. Well, notice since the particle is very fast over here, it should be able to finish this very quickly. So t1 must be small and the time taken from here to here must be larger because the particle is slower here. I hope that makes sense. And so we would predict that t1 should be smaller than t2. But we want to calculate what t1 by t2 is. That's what we need to figure out. Okay, so to do that, let me assume that the particle is over here at t equal to 0. That makes things simpler. So we have to assume a function for x at which it goes to 0. The position is 0 at t equals 0. And that function is very easy. That's just sine function. So I'm going to choose x equals a sine omega t as our function. Okay, so notice that when t equal to 0, x goes to 0 because sine 0 is 0. Alright, now what we need to do is we need to figure out at what time it hits a by 2. So what we'll do is we'll put x equal to a by 2 in that equation. Then, and let's say time taken be t1, that's this time. So then we'll have a by 2 is equal to a into sine omega t1. This cancels, you get half equals sine omega t1, and that gives us sine of theta is half. That means theta must be pi by 6. Now we know omega is 2 pi by t, capital T, so that should be pi by 6. Pi goes, so we get t1 as t by 12. So the time it takes is 1/12 of the entire time period. Okay, let's now repeat the calculation. Let's figure out the time it takes to go from here to here directly. That's easiest. That's easier than calculating from here to here. So let's first calculate the time it takes to go from here to here, and then we just subtract this time, right? So in this case, we're going to substitute x equals a. Let's calculate how much time it takes. In fact, you know what? This is not even needed to be calculated. We know the time it takes to go from here to here is the same it takes to go from here to here, and from here to here, and from here to here. In fact, the time it takes to go from here to here is t by 4. You should know that by now. Okay, anyways, I'll prove that to you. So let's do it anyways. So if I put a equal to a sine omega, let me call that as some t3 or something. So that is the time it takes to go from here to here. Okay, so 1 equals sine omega t3, and t3 into omega should be equal to pi by 2. So 2 pi by t into t3 is equal to pi by 2. So t3 is capital T divided by 4. There we have it. Okay, so I told you the time it takes to go is 1/4, but that's not what we're interested in. We're interested in calculating time t2. That's t3 minus t1. Alright, so that turns out to be t by 4 minus t by 12. If we take 12 as a common denominator, we get a 3 minus 1, that's 2t. Oops, that's t divided by 6. So there we have it. We now know what t1 is, it's over here, and we also know what t2 is. It's over here. So we want to calculate what t1 by t2 is. Let's do that over here now. So t1 divided by t2 turns out to be t divided by 12 divided by t divided by 6. As we predicted, t1 is smaller than t2. Notice it's 1/2 compared to t2. So that gives us 6 by 12. That's half. So t1 by t2 is half. And that's our answer.